All right, this video is going to cover section 4.2, least squares regression for statistics. All right, line of best fit, least squares regression, linear regression, those are all terms to describe the same thing. Essentially, it's a line that can be used to make predictions about data. Predictions about data. So we talked a little bit about this in the first one, but just like when we were making a scatter plot, we would put X into L1 and Y into L2. So you take your calculator, you hit stat, and you type those in there. Oops, clear, enter. So L1. Enter. There we go. 103. So you just type these in L1 and L2 like we did in 4.1. Now, if we wanted to have our scatter plot, we would make sure our plot is on and zoom 9. There we see our dots. Now, a line of best fit or a linear regression is going to go through that, and be useful. So, actually, bring that back. In order to get that equation, you're going to hit stat, arrow over to calc, and then choose number 4, linear regression. This is the same thing we did to find R. And then you want your X list to be L1, your Y list to be L2, and then this is a great place to store your equation. So if you hit the vars button, that's going to be this one over here in this row, vars. Then you're going to arrow over to y vars, y variables. Choose 1 for function. And choose 1 for y1. That's going to, not in the frequency list, in the store. By putting that in the store, that's going to say, hey, calculator, I want you to write whatever you get for the function in y1. So that purple part, I'll show you what it does in a minute. Then you hit enter on calculate, and you get this. Now, it's in slope-intercept form. So just like before, y equals mx plus b, they're just using a and b. So a is your slope, b is your y-intercept. So you can write that out. A is 3.1661x, and B is negative 55.7966. So that would be the equation of our line, and we can use that to make predictions, which we'll talk about in a little bit. Now, if we hit graph again, from where I had that scatter plot, by storing this purple thing in y1, that's what draws the line there. The calculator wrote that equation in y1. If you don't store it, you can type it yourself if you end up needing it. But now that line can be used to make predictions. So we'll come back to that. If you were asked to interpret the line of best fit, that just means put it in real world terms. So here we're talking about speed and distance, and slope is y over x, change in y over change in x. So if I were to interpret this slope, 3.1661, to make that a fraction, it'd be over 1. So for every, I guess I'm going to have to go over here, for every increase, every 1 every increase of 1 miles per hour, or whatever that speed was, that's the 1. The distance increases 3.1661 feet or miles or whatever that message was in the first one. So you're just taking those numbers and adding the words for this context to tell you what it means. A big thing to pay attention to is the scope of the model. So does it make sense? Now our y-intercept for this is negative 55.7966. Our y is distance. You can't go a negative distance. You just can't. Even if you go backwards, you're still going a positive distance. So we wouldn't interpret the y-intercept because it doesn't make sense. So y-intercept, not realistic. We still need it there for the numbers, but it's not within the scope of this model. Also, all of these speeds are around 100. So if I wanted to know how far the ball would go if it was 10 miles per hour, that 10 is really far away from the 100, so this model might not help. For the same as if I said, what if I hit it 300 miles per hour? Those numbers are outside the scope of this speed, so we wouldn't use that model. We also talked about in 4.1 finding out if something was linear or not by saying, is the absolute value of r greater than the critical value? If we say yes, then we use the equation to make predictions. So whenever you see y hat, that's talking about the equation. So this over here is y hat. If we say no to this, then you're just going to use the mean. You find the average of all the y values, and that's your answer. Now, a residual shows you the difference between the observed value and the predicted value. The other way to think about that is the observed is the actual value and the predicted is your equation. So let's see what a residual would be for this point. So 105, 277. What's the residual? So that is our actual value. The 277 is the observed value. To get the predicted value, we plug this into the equation for x. So we would do 3.1661 times 105 minus 55.7966. And if I type that in a calculator, I get 276.6, so 277. So in this case, we would do 277 minus 277, and we would get 0. The residual 0. It's not always going to be 0. The last thing to point out in this chapter is in statistics, always round to 4 decimal places unless you're told otherwise. So anytime you're rounding, unless something different, go to 4 numbers after the decimal. That is 4.2. Let me know if you have any questions.